Hi, and thank you for joining me. I will talk today about how not to, or how actually to use JavaScript together with machine learning to beat cancer. There is here in the title is for some purpose because obviously JavaScript isn't really the best language for machine learning. I will explain it later during my presentation. So why when I talk about cancer, I have in mind skin cancer specifically. So this is a topic that I'm doing for 15 years now. I do research in this topic for 15 years before machine learning was so cool. So that's something that I'm specializing. I'm not a dermatologist. I did a PhD in this topic. I have published some research papers in this topic and also commercialized some of the solutions based on well, Python in the back, JavaScript in the front, but actually it's machine learning in the back. So here we go. As I said, I'm doing it for 15 years now. I mean, machine learning in general, mostly in the medical field, medical imaging, skin cancer, but also recently some other topics together with hospitals, medical doctors, solving challenges that doctors work. I mean, some challenges they have on daily basis and try to automate that, solve it, and build some models that automate some of the process, like for example, finding for example, the cancer on different kind of images, not only skin cancer, but also breast cancer, brain cancer, and so on. So the research that I'm currently working on mostly are dedicated to are in the medical field, but the company that I'm CTO of, PROIDEA and MedTransfer, is actually specializing in the medical field, in the medical imaging. Where actually PROIDEA additionally do also research, machine learning research in a wider in other areas, like for example automotive, finance, and so on. You can also find some of my papers. Here's one of the, let's say, latest one. I mean, latest 5 years ago. This is a result of my PhD thesis I have. I obtained my PhD in 2017, and this is also a paper that is based on this thesis. It's about multispectral skin patterns. I will explain that a bit later during the presentation. What is a skin pattern? I mean, pattern of a specific illness of skin. But actually, if you want to learn more, obviously you can take a look on some of my papers. So the agenda for this meeting is actually, is it possible? How can we use machine learning together with JavaScript, or how to use machine learning in JavaScript specifically? A few more words about skin cancer. What is the skin cancer? How actually you find the skin cancer on images? I will show you the demo, how to do it, and where to go next. So what are the pros and cons of using JavaScript for together with machine learning in the back? So, as I said, I'm doing it for 15 years now. The goal here is actually to, help and fight against cancer, and skin cancer in this case. But also I do, or what is the purpose of this project, or one of the part of the project is actually that I have signed some contracts and collaboration partnership with dermatoscopy companies. You can see here, for example, I'm not sure if you see it. I would just put it on the front of the camera. That's a dermatoscope together with an iPhone here. And obviously the application that I have developed is a mobile phone like this one. That is actually combined together with this dermatoscope here on the front. And this has a specific optic actually to make photos of obviously skin moles. So that's one of the reasons, obviously, why I cooperating with some dermatoscopy or hardware actually companies. And well, the thing about dataset is that now we have also open dataset for research purposes. So not for commercial one, but for research purposes. It's called ISIC. If you want to start any kind of research on skin cancer, that's probably the first place you should reach. When I started my research 15 years ago, our dataset consists of 53 images. You can imagine 53 images of skin moles. ISIC dataset that is now publicly available for everyone consists of 26,000 images, right, of skin moles. So the difference is huge, and now obviously the ways of research are possible in different directions, not just finding distinguishing between cancer and not cancer. Still, most of the challenges, if you go to the ISIC challenge website, are actually about finding specific illnesses, like cancer, for example, which is only one of the illness of the skin. And that's not the right approach, in my opinion, because the research that I'm doing is dedicated to patterns, not binary or multi-class classification between illnesses, but also specifically into finding out about the patterns, what's in it. For purpose of this presentation, I have prepared also a Docker image for you. If you would like to start working with machine learning and JavaScript, you can download one of my Docker image where actually you have all of the whole environment installed there. There is obviously Jupyter Notebook with the JS kernel and the most obvious libraries that I need to do this research. So the first POC of architecture of the first POC that I have managed was actually, actually the question at the beginning that I had was, okay, should I build a native application using Swift, Kotlin on the mobile, or maybe just going directly to JavaScript and actually building an app for both platforms, especially actually when it comes to the different kind of mobile phones. That's our iPhone 6s, but obviously this extension can works with different phones of different sizes and models. So that's why I decided to actually go with React Native. There are other ones like PhoneGap, Cordova, X-React, and so on that you can use for building apps, mobile apps in JavaScript. And this is also combined with Tensorflow.js, which is that's TensorFlow in general. That's one of the most popular. I think that's the second most popular library when it comes to machine learning. In Python, there is a fork that is called TensorFlow.js that I would like to also show you today how it works, more or less, because obviously I cannot share all of the details that I have of the development. So why to choose JavaScript? One of the reasons I have already shared with you, but obviously machine learning engineers, data scientists, they prefer more Python, Scala, or Java to do actually the research, to do that app, the model. That's an obvious. There is an obvious reason why to choose actually Python. But actually, if you compare it to JavaScript, and check how many libraries you have, you will easily figure out that actually JavaScript has much more libraries for machine learning compared to Python. That's very interesting. Why that actually there are more libraries in JavaScript, but as you know, that as the joke says, every week you have a new JavaScript library, and that's totally true. When we take a look on the machine learning libraries, you have plenty of libraries, but most of them doesn't work. That's the thing when it comes to JavaScript, right? So why I decided to use TensorFlow.js? I use TensorFlow.js not really for training the model, right? That's obviously a very time-consuming part, but actually I use it more for loading and predicting of the skin balls, obviously. So it can be easily copied also to web browser. For example, if we want to change from a mobile phone to a web browser and a camera, then it's an easy way to do it in JavaScript rather than in Python, mostly. Especially in Python, obviously, technically it's possible to write an Android app in Python, but it's a bit harder to do it compared to Kotlin, and not recommended at all. So in production, there are two ways of how the app works. So the first one, the model is combined with the main app. I'm executing it on the mobile app. So the model is loaded together with the app, and then it's predicting. But because of the app, it needs to be, the model needs to be retrained. We need to adjust it, make it better. We have also a TensorFlow service. In general, when it comes to production-ready, production application, commercialized models, we should also use a solution like Kubeflow, for example, and TensorFlow service is one of the ways how to actually to combine and check, give actually serve the model for in production. In my case, I collected the data to really retrain the model and obviously update it on the mobile phone to adjust the model and actually make it even better than it is now. So that's a typical procedure because that's a part of the machine learning process of not only predicting, not only training, not only predicting, but also retraining. That needs to also be done in a proper way because there are plenty of cases where actually production-ready model fails because of the retraining if it's not secured properly. All right, so let me show you just a few examples. I have some notebooks prepared for you. Here we go. That's partially from a notebook that I have on GitHub. You can obviously find some of the notebooks on my repository, on my company repository. Here's an example of how to use JavaScript for data analysis, data pre-processing, actually, because before you do build a model, you should do the pre-processing. And there are two popular libraries for actually manipulating data in Python. One of it is called Pandas, and there is a fork of Pandas in JavaScript called Pandas.js, as you can see here. We can build data frame series with that, with this library. Similar, or even in some cases, even exactly the same, like in Python. So that's something that I also used, or you should actually use when you want to do research or do some data pre-processing using JavaScript. I'm not a JavaScript, I mean, from what I'm doing, I mostly use still Python because that's the language I use for building models in most cases. But still, as you can see, it is doable also in JavaScript. Here's some series that can be loaded. Just an example, a data frame. That's used on data frames and series in general. Pandas is used to actually manipulate heavy data to collect and do some manipulation, like here, for example, filtering and so on. There are also some limitations. It's not perfect. I mean, the solution of written in JavaScript, it's kind of a fork, but it's not yet fully. It doesn't have so many features like the pandas in Python. That's why most researchers still choose Python. One of the advantage of JavaScript is we have many libraries for visualization of the data, plotting data like matplotlib and so on. But in JavaScript, we have more easier to use and just better libraries, in my opinion, compared to the Python ones. So that's a huge advantage of JavaScript. For example, just to mention just 3 libraries that I use. And well, unfortunately, scikit-learn, that is the most popular, in my opinion, it's the most popular library because it is a library that consists of shallow methods, shallow machine learning methods. There are some ports like JS-kit-learn or scikit-learn in JavaScript, but they are not really maintained. So it's a shame because it's well, most of the machine learning challenges problems that are solved using shallow methods. So that's not good, and this is another reason why JavaScript isn't so often used for machine learning. But actually, TensorFlow.js, that works, as you can see here in the image, as the name says, we have tensors, which are the blocks here, and the flow, which are the lines here. As you can see, it's a linear regression, right? Written in TensorFlow. You can easily use it to actually build any kind of graph, any kind of equation here, and machine learning is nothing else than just an equation under the hood. Plenty of equations, really, and then math operations. So TensorFlow is one of the second most popular, in my opinion, library for for machine learning. When it comes to JavaScript, because it has has some layers under the hood. You have layers of data sets, and also the engine that is actually written in C++. So Python is just, it is just a front, an interface for that, and this can be actually copied to different languages, and we have different copied to different languages. For example, in Java, Go, or JavaScript. That's a good. That's a good thing, because we can use Tensorflow.js with, if not all, then most features it has also in Python. So that's a good point, and that's why this is when you do machine learning in JavaScript. In most cases, you will choose probably Tensorflow.js because of the major, because it's major in JavaScript. So it's just building properly. Here you have an example how to combine that, right? How to implement the linear regression in JavaScript written, and you have also the algorithms like the gradient descent algorithm, for example, together with the learning rate to just find out the prediction. Easy to use also in JavaScript. Here's obviously an example. More complex networks, because now most people hear not only about the shallow method, but mostly about the deep learning neural networks. One of the library that is connected with TensorFlow in Python is Keras. Keras is now they're even very integrated, really. So we can use Keras API from TensorFlow, TensorFlow from Keras, but actually mostly Keras from TensorFlow, but actually they are integrated. But Keras is has blocks that you can use to build the network in a faster way, let's say, and Keras is an obvious competitor to PyTorch, in my opinion. Now it's the opinions are divided, which of the solution is better. But I would still vote for Keras because it's based on TensorFlow, and it's more robust and it's used in commercial products for years. So one of the example here, you have an outer encoder network here on this example, and still in JavaScript you have Keras.js, right? Here's an example, but it's not exactly a fork, it's not exactly a copy. You can still use Keras.js to load the model that you have built in other language, for example, in Python. But it's a bit limited compared to the Python version still. So when it comes to JavaScript, good. It has support for GPU, especially in the browser, right? Also on the mobile. It can be used easily for predicting some basic stuff, or loading the models that are more complex on your mobile and web, obviously. Just a short overview of the tools we have. So let's just go straight to the Tensor. So Skin Tensor, that's it is. I mean, the research is obviously based on images on skin moles using this kind of devices I showed you before. There are some researchers, there's some applications that are simple ones, in the meaning that you don't need the whole optic here, but it's in my opinion it's not good enough to really, if it's an obvious Tensor like the one on the left or the one on the right that you can see now on the screen, then you don't need an optic. But if this is not an obvious case, like the one in the middle, then this optic is crucial to really do the diagnosis. And as you can see here on the left, we have some patterns. I see the patterns because I work with skin moles, with skin cancer for plenty of years. For many years, there are some dots, kind of a gray dots there. The stripes here, unstructured mole, and so on. So there are some specific patterns that tell us, okay, that's an advanced cancer, right? that's something that we should care about in the first place. The same on the right. Even it's not so asynchronous, it's not so asymmetric. We still see a kind of a blue, white, gray pattern in the here that is specific for advanced level of this cancer. So it's going deep in the skin. It means, oh, that this can be dangerous. It means that's an advanced cancer, and we should care about it very, very fast. All of the images you can see here are done using typical visible light. That's something that also you can use with a mobile phone without any extension kit to some degree. But there are some other ways how to get images of skin moles. Here in the middle, you can see it's kind of not symmetric so much, but this is not a cancer. It looks on the first look, it looks like a cancer, but actually it's not a cancer. Why I know for sure that it's a cancer or not, because to all images I have a description of the histopathology description of this mole. So it was cut off and then actually sliced into small pieces, and the cells were checked if there was a cancerous cells or not. So how do the medical doctors do the research, or how they actually find out if it's a cancer or not? Most dermatologists will tell you, well, I take a look and I see, right? Because of the experience, mostly. But actually, there are some scales or some scoring methods that are typical for skin cancer, like ABCDE, for example, 7-point score method. In my research, I used actually mostly Hunter score because it is based on multispectral images. But actually, there are more than 30 different patterns specific for melanoma, which is just quite well, one of the worst skin cancer or cancer in general, because it's progressing very, very fast. So you can imagine that actually the topic is quite complex. For now, we have automated about 15 patterns so we are able to find patterns specific for melanoma or specific for non-melanoma cases, because there are different kind of illnesses, not only melanoma, with some specific pattern. You can imagine COVID-19 has also some patterns, skin patterns that are specific just for COVID, right? It's not yet so, there are not so many papers on that, but you can find especially when it comes to the kids and the skin, not moles, we can tell that are visible on the skin of children's that are specific for COVID-19. So not only cancer can be figured out based on the patterns of the moles of the skin. Similar with other infections, like the liver infection, for example, of the type B, can be figured out during with an analysis of a mole. And here you have an example of similar moles, but actually using different kind of wavelength of light, infrared and UV. So you can see here. I know it doesn't look pretty, right? That's something that probably you didn't want to see on your own skin, but that's how it looks actually under the hood. Because with infrared, we can find out what is actually where's the hemoglobin. So what is actually because the cells are reflecting differently to different wavelengths of light, and infrared. When it comes to infrared, the hemoglobin, so what's part of our blood, is actually reflecting to infrared. And you can see here where we have accumulated blood, like here, or lack of it, right here. In both cases, it's dangerous. It should be more or less flat for when we talk about a mole that is not a cancer, right? And that's not malignant. And here on the right, you have an image that that was taken using the UV wavelength of light, UV light. Well, on the first look, it looks good, but you can see the dots here, small dots, white dots. It means it's penetrating deep into the skin. So that's also dangerous, this kind of dots. Because when we talk about skin cancer, when we talk about melanoma, you can be healthy, fully recovered if you cut the mole off fast when it's not yet too advanced. It's not go too deep into to the blood vessels. If it goes too deep, then it's spreading through in your whole body. So that's why it's very important to actually react fast. Apart from that, something that I also try to do with JavaScript is to actually do some image processing. There are some good libraries to do image processing in JavaScript. Still, I think the libraries in Python are a bit better for that. Even the visualization libraries in JavaScript are better, but for processing, I think in this case, Python still wins this challenge. You can see here that if you do a segmentation, binarization in this case, which also is kind of a segmentation, you can see that actually some of the patterns can be visible, right? Like here, you can see this mole is divided into two parts. And it's asymmetric. It has a shape. The border is sharpened. So there are typical patterns of a malignant case. Here we have a mole that isn't so bad. I mean, you can see it's not super symmetric. It's the borders are sharpened, but in general they are not so big. Missing of, let's say, of the black color here and here, just a few. So it's not so bad. That's not a malignant one. And here another case of malignant. These images were made. I used multispectral images here. So this binarization was done on images on different levels, right? I mean, just to understand, so you don't understand me wrong. Skin has some levels, but they are not like it's not like in a cake. It's more chaotic really. But using the different wavelengths of light, we can more or less find the layers in the cells in the layers specifically. And you can here on the right you can see a big missing here in the middle, and this is obviously a pattern that is will tell us that's a malignant case. Just these the three examples here are just very simple ones, just not to go deeper into patterns that are not so obvious, and especially when you use binarization like I did in some of the examples. You can see here you can actually do a zoom and find out, okay, that's the border, because that's part of the ABCD scale, right? A symmetry, border, number of colors, and differential structures, or diameter, depends on the paper that you read actually about it. And here you can see that the border is quite sharpened, so it's not smooth, right? So that's a bad pattern, but actually just having this as a pattern is not enough to actually distinguish between a malignant or non-malignant case. All right, so let me show you two more things. A few notebooks again. How I proceed with some of the cases, or how you should actually do that, or how it is done. In this case, I actually show you in Python just because of the image processing methods are just better in Python. Again, as I said, I'm doing it. I'm using machine learning. I'm using Tensorflow.js for the prediction in this case. So yeah, you can see there's an image from ISIC, and actually the first step in general is just to remove the skin that is surrounding this the mole. Why? Well, on one hand, there are 6 phototypes of the skin, right? So there are 6 types of colors of the skin, specific for 6 phototypes and 6 colors of the skin. So depending on that, what kind of phototype of skin you have, there is a higher probability that you might have skin cancer in the future. For example, if you're blonde, blue eyes, and when you go on the beach, you become let's say pink I mean, your skin become is actually getting in this direction, this color, then you are more well, there's a higher probability that actually you will have a cancer, skin cancer, rather than someone that is actually, I don't know, people from Latin America, for example. The skin color is a bit more, let's say, in the direction of brown, and that's this kind of persons, like I, for example, are actually not. It's less probable to get a skin cancer. So first of all, it's actually removing it, because that's obviously can distinguish, or actually consider some probability. Also, age might be an important factor, but here, when it comes to the research of an image, it's important actually to find out, take a look on the specific more, like here. Right, so we are getting it off, giving the skin color surrounded, because as you can see here, the object is also in a circle, so you actually get a circle here inside, and then the rest is might be dark, like here. Doesn't need to be like that. It depends on the dermatoscope that you use, or video dermatoscope, but it might be like that. So what is interesting for us is here. All right, some other new notebooks. Here's an example, actually extracting the region and checking asymmetry. Here we go. So you can see we are extracting the region of interest here, trying to find out, okay, that's the part that is interesting for us here, all right? And this is what we want to analyze. There are just a few examples. All of them are not looking good. You can see here, the resolution is not so important. I mean, it's important to some degree, but actually having a higher resolution image doesn't always give you better results in case of skin cancer. So what we did, or what is actually done when it comes to the asymmetry, that's an obvious patterns, right? So that's something that you can find plenty of articles about it. It's actually to divide the image or the mole into 8 sections, or make a map like here, right? To find out how is the symmetry compared of the regions on the opposite side here, right? And you can obviously get some images to find a symmetry factor, right? That's how you can do it to implement the A from the ABCD scale. All right, that's just one of the examples. I don't have enough time to go through all of them, but you can find it on my GitHub account. More to kind of check and analyze. So what is the app about? That is a very simple app. Here, as you can see, that's obviously very, very basic. Here you can find out that we are taking a photo, and there are some random data here. And in this case, we have only the A, B, and C, which is the most basic, 3 most basic patterns that are analyzed and checked if this is really there. Well, actually, in real world, it's not only about true false of a pattern, but in some cases like ABC, the scoring method, we also giving points, right? For asymmetry, we have 0.2. From colors, we have from 1 to 6, and so on. So we are adding the points and then actually getting a score, and we have a threshold. Actually, we distinguish it, so if it's a suspicious one, malignant, or non-malignant one. All right, just to summarize, how to use machine learning or how not to use. I hope I haven't tell too many bad things mentioned. I mean, JavaScript is still a solution that language that can be used for machine learning. Compared to other languages, it's not so bad. I mean, you can take a look on Ruby, for example, or many other languages that actually are much worse for when it comes to machine learning, and how you cannot really use some of the languages to machine learning. JavaScript, still, the maturity of many libraries are not so good. But what it's good for is for prototyping, like I did for my mobile phone. That's something that it's a very good solution. Not developing native application that takes more time. JavaScript, you know, is a very easy language compared to other ones. I think even it's, well, I have some comments on that on the language itself, but still it's not bad for using it for prototyping, especially in machine learning. There is a huge community. Everyone knows, based on GitHub repositories, JavaScript is the most popular language now. So we have a huge community. Works in different mobile phones, different kind of web apps, because you can easily move it to a web application as well. On the other hand, well, even the community is big for JavaScript. When it comes to the community of specifically machine learning related topics, it's still not big enough. It's still lacking of well, first of all, for libraries, most of the libraries are obsolete, so obviously the support is not really given here, because you just cannot use a library that is not that is obsolete, not really maintained, and is not robust enough. Especially for production-ready commercialized solution. And second thing, or third thing actually, the MLOps, so Kubeflow, that's also I would say there is almost nothing. Even Kubeflow, there is many scripts that are written in also in JavaScript there, but still, when it comes to support of MLOps tools for that, that's quite limited. So that's another thing why actually JavaScript is not the first language or even the second language that is chosen by the data scientists and machine learning engineers. So that's why you know, still a good option, and I see many applications where actually it can be used, like the skin cancer case that I showed you, but well, there is still room for improvement when it comes to JS and combining machine learning. So we have still 4 minutes, so I hope you have some questions to me related to this topic. Yeah, thank you for now, and waiting for the questions.